Welcome back to the channel. We're back on the 8-horse Mogul project. This detent lever here is broken. Somebody hit it with a hammer, I'm sure, and this slides back and forth. We're going to have to make a new piece for that, so we're going to turn a piece on the lathe and see if we can get this repaired by having that piece welded on there by my welder. So let's get to making parts. Over on the lathe here, we're going to be working with a piece of Durabar, which is extruded cast. It's cast iron that's extruded under high pressure. It's very homogeneous and really good material. So we're going to be turning this down to make a part that is about 3 inches in diameter. There's a zoom in. You can see I'm taking a pretty light pass because I have quite a bit of overhang on this part. I'm not using a tailstock here because of just the filming angle more than anything, but I think it's going to be okay if I take a light cut. I'm going to be taking no more than about a 40 thousandths cut after I get going here. We're making a continuous cut here, so that helps. I'm going to be turning this down, like I said, to 3 inches, and then we'll part that off. We'll see how it goes. One thing to note is the lathe is actually turning about 400 RPM and it's rotating towards the camera. The problem is the camera aliases the speed down, makes it look like it's turning the other direction pretty slow, but it's actually turning about 400 RPM, making about a 40 thousandths pass here. My feed rate on my carriage is pretty slow because I want a pretty nice finish on this, and this Durabar machines really well. It actually machines about like steel. Makes chips instead of the dust like regular cast makes, but it makes nice chips and it's really nice to machine. Well, looks like we're down to dimension, so now we'll part the piece off. Going to be using the parting tool here. I think I can get away with this. I do have a lot of overhang off that chuck, and that's not ideal, but just making sure that the tool height is right with that little scale. If that scale is vertical, then the tool is in the right place. Too low and it's going to grab, too high it's going to just rub against the part and not cut right. Typically for these parting tools you want them in pretty close to the chuck because they do have a lot of tool pressure, and that can move the work around, but that's not what we got going on here, so I'm going to try to do it this way. If that doesn't work, then I'll go to plan B. Okay, about a 1/4 inch into the cut here. I use a lot of oil on these parting tools. Tool pressure is very high, like I said, so I use a lot of oil. Seems to be going okay. Still kind of nervous here. The tool height isn't quite right. Here it's trying to bite into the material, so I'm back that off and see if I can get it going. A little more oil there. I'm always nervous about parting parts off. It just never goes real well on these larger diameters, especially being so far away from the chuck. So yeah, we'll just see how it goes here. Hopefully we can get some distance out of this and go from there. Oh, you see that? Wobble there? The tool actually grabbed, so we're going to have to go to plan B now for cutting this off. Well, to start with, the part moved in the chuck, so we're going to have to take the chuck key and readjust that part. It needs to be square to the chuck for proper holding, so we loosen the jaw up there, slide it back in. It moved out about 1/8 of an inch actually. Kind of surprised it didn't come out of the chuck, but it sure didn't. So we'll get that trued up, and then plan B will be the portable bandsaw. Going to be putting a board underneath the chuck here for 2 reasons. One, to catch the fine chips from this bandsaw, and number 2, to protect the ways of the lathe. when I cut through with that bandsaw so the blade doesn't ding them up. I really like this Milwaukee bandsaw. It cuts real nice. It's real easy to control and cut straight. So I put the lathe in both back gear and regular gear. That locks the head so it can't turn. So we'll get to cutting here in just a little bit. And here we go using the bandsaw. I'm going to part off a piece that's about 3/8 of an inch wide. It's a little bit less than that, about 350 thousandths. That's about the right width for this part that we need to put on that shaft. And I really like this saw. It works better the slower you run the blade. It's just easier to control. So we'll get this parted off and head over to the table and start making the template for cutting it out. Over on the bench now, I'm going to use this piece of cardboard to make a template for the shape that we need to transfer to the metal disc that we just cut off there. So I'm going to use this shaft as a registration point for my template. So I'm just going to cut a notch out here and make it so we can trace the shape of that broken section. It just needs to be approximate. It doesn't have to be perfect because there will be some grind to fit with the welding process. So this will sit on there. You see how that is, and then we can trace it on the other side here. Okay, flipped around to the other side with the camera. You can see what I'm going to do here. There's my notch for registering to the shaft, and then I'm just going to take a pencil here and make a basic trace there for the bottom part of the piece. Trace up the side just a little bit there for registration, and then to get the top part of it, I'll just rotate that collar around, and that will be the top piece. It should be at the right height to weld on there and carry that circle on around. So we'll just mark that real quick, and there it is. Just kind of color it in here a little bit so it's a little easier to see. I'll bring it up to the camera here shortly, but there is the basic piece that we need to cut out of that disc. Used a Sharpie to raise the contrast of that tracing just so you can see it a little better. We're going to cut that out with the X-Acto knife here. Basically, I'm just going to cut on the outside of this trace line here. That will add just a little more material and give the welder a little bit more to work with. We can always grind off. It's just really hard to add after a part's been put on there. So just going to keep cutting this out and get the piece ready to go. While I work away here, I'll talk a little bit about that detent. What that decompression detent does is it changes the timing of the exhaust valve so that it stays open part of the compression stroke. That allows a lower compression to happen while you're starting the engine so you can actually roll it over. Otherwise it's very, very hard to start. And this repair isn't necessary for that operation. It's just cosmetic, but in this restoration process there are structural problems that you have to fix on these engines, and then there's also stuff like this that's just purely cosmetic, that's just abuse of the engine. Parts get broke and you just fix them so that they're back to what they were when they were new. So that's what we're doing here, is a cosmetic repair on this collar. The guy that does some welding for me is going to weld with nickel rod. There's different ways to do cast, nickel rod, some specialty rods, and then also brass. But in this case we're going to use nickel rod, and you see that there, I broke that piece. It's a good thing I made another one off camera so that I can keep working here. I proved out my theory before I did this all, and I'm just going to use that one because I broke the other one. I tore it with the knife. So now we're going to transfer this to the metal disc and cut that out with a portable bandsaw. There's the piece that we need, and that's a rough piece. I'm going to do some grinding and fitting on that, but this bandsaw is back in play again. It's a major part for this project, so just going to part that off. Kind of a difficult thing to get clamped to the table there and get it held right, and then try to get the bandsaw in there in the right place. But we'll see if this works here. And there you have it. There's the part cut off, and here's the final shape ready to go to the welder. Shifting gears a little bit here, I've been doing some painting on the base and the cylinder. I need to get this base coat done so I can take it and have the pinstriping done to the base and the cylinder. This engine has some basic pinstriping, not as much as like the Galloway and the Galloway video, but it does have some pinstriping. So I'm going to have to take it to the pinstriper for that, but I need to get this base coat paint on here and get all my prep work done for that, because I certainly don't want to do it after it's pinstriped. I tend to brush all of my engines. Some people spray them, and that's fine, but I like to brush, and I just enjoy painting engines. I don't like doing any other kind of painting, but painting these engines, I do like that. So this paint flows out real nice and just works really well with these engines. So I put one coat on this engine so far. I'm going to go back here and put a second coat and maybe even a third coat just to keep evening it out, and then get it to the pinstriper. So anyway, that pretty much does it for this video. Thanks for tuning in and making it this far. Some of the footage was kind of hard to film for this one, and just took me a long time to get through it. It's just a little difficult angles. I'm still learning how to do that on the lathe especially. So I appreciate your patience on that, and if you like what you see, like and subscribe and leave a comment, and we'll see you in the next video.